We're going to take a look at graphing a secant wave. And we'll state the period, also the amplitude, the phase shift, the vertical shift, and let's see something else. We'll find out. So let's take a look at this. Now first off, secant, the reciprocal of secant is cosine. So I want to think cosine. Further, I want to think with the minus sign. Normally our cosine starts at the amplitude, and after the period it's back to amplitude, and halfway in between it's at the lower amplitude, and then it crosses. That's our normal cosine wave. However, because of the minus, we're actually doing starting at the bottom after a period ending at the bottom, half of that period at the top, and in between at amplitude, at baseline. So this is actually the cosine wave that we're going to be basing ours off of. But for all of the information, I want to look at y equals minus cosine x minus pi thirds plus 1. So the amplitude is the absolute value of the coefficient of the function, in this case 1. The period is the normal period for the graph we're dealing with, which is 2 pi for cosine, divided by the coefficient omega. The coefficient of x, is omega, and that's 1. So in this case it is 2 pi. The phase shift is what makes the inside stuff of the trig function 0. In this case we can see pi thirds minus pi thirds would be 0, so our phase shift is pi thirds. And then vertical shift would be the constant term. It's usually on the right, sometimes it's written out in front, but it's the constant term. In this case is positive 1. There we go. Now with the period, it's the sine and cosine and tangent and cotangent. All of those functions in general are based off the unit circle that has 4 quadrants. I like to take the period and divide by 4. In this case it would be pi halves. And then compare pi halves and pi thirds to get an idea of how to set up my tick marks. Now with my tick marks, pi thirds and pi halves, I'm actually going to generate the common denominator. And I'm going to have my tick marks based on pi sixths. And I'm going to put them, every one of these little lines is going to be a pi sixths. So that's going to be pi sixths, 2 pi sixths. You could label it 2 pi 6 if you want. 3 pi 6, 4 pi 6, 5 pi 6, 6 pi 6, 7, 8, 9, 10, 11, 12, etc. And by using a common denominator, we're going to be able to get both the pi halves period. What's pi halves? It's 3 pi, oh wait, hold on. Yeah, that's fine, 3 pi sixths. So every 3 of these, we're going to be going through these spots, every 3 of our tick marks. And then phase shift, this is 2 pi 6. We're going to start to the right 2 of these tick marks. In some ways, figuring out how to label the x-axis tick marks, if you get those right, everything lines up nicely. If you don't, it gets difficult to put the points where they need to be and have the period the size it needs to be. So again, I work out the period, divide that by 4, then I work out the phase shift, and then I take a look at those, and if they're whole numbers, I pick the smaller one for the tick mark size. If they are fractional, I take the common denominator for the tick mark size. And that way everything lines up nicely. So our normal cosine wave would start at amplitude, but because of the minus, it starts at down at amplitude. Our vertical shift is 1, so let's have this be 1 right here. That's our baseline. That's going to be the center of our graph. And then from there it goes up the amplitude 1 and down the amplitude 1. So we're starting up 1 and we're starting the phase shift right 2 tick marks. Normally it would be here. Let's see. So there's so many things to consider in graphing this. So normally this would be the baseline. The cosine would be up 1 from there, but it's down 1 because of the minus. So this is our starting point right there. The period, 2 pi, is 12 pi sixths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. After a full period, it'll be back to that point. Halfway in between, which would be 1, 2, 3, 4, 5, 6 of them, it's up an amplitude. Then halfway between those, 1, 2, 3, it's a baseline. 1, 2, 3, it's a baseline. This would be our cosine wave. We don't want to actually sketch it because we're not trying to sketch the cosine. We're trying to sketch the secant, the reciprocal. All right, so once you figure out the tick marks, take a look at your period. The period's 2 pi. That would be 12 pi sixths. That gives you the 12 tick marks for a period. And the phase shift is pi thirds is 2 pi sixths. The phase shift is 2 tick marks. So we're right, 2 tick marks. Normally the cosine would be up in amplitude, and that's 1 from baseline. But since this is a minus cosine, we're down 1 from amplitude, from baseline, sorry. So we start here, then up, Review this, go back over the video part if you need to make sure that these points for the cosine wave make sense. Now, where the cosine wave is at its baseline, the secant would have an asymptote. Where the cosine is at baseline, the secant would be 1 over the baseline. The baseline is normally at 0. 1 over 0 is undefined. So everywhere the underlying cosine wave has baseline, you have an asymptote. Everywhere the underlying cosine wave is at an amplitude, that's where the secant takes off towards infinity. This represents one cycle of the secant wave. It is kind of awkward not having the other side of these little pieces, but that's one cycle. The pattern in between these tick marks, 1, 2, 3, 4, 5, 6, so 1, 2, 3, 4, 5, 6, you can continue to create more and more asymptotes. 1, 2, 3, 4, 5, 6, as many as you want. You can continue this pattern so that you could then finish this little section if you wanted. But given the instructions to graph one cycle, I'm going to leave the graphs like this. That's one cycle. Now, one thing that might be asked, the frequency. The frequency is 1 over the period, always. So in this case, since our period was 2 pi, the frequency would be 1 over 2 pi. They could ask about the asymptotes. Now, how far is it between asymptotes? 6 tick marks, but a tick mark is pi sixths. If I multiply that by 6, it's pi. So the distance between these asymptotes is pi. So take the first asymptote. Where do we have this? This is at 1, 2, 3, 4, 5 pi sixths. 5 pi sixths plus k times how far to the next one? Pi, where k is an integer. If the question was domain, you basically copy all of this down, but have a set of x's such that x is not equal to 5 pi sixths plus k pi, where k is an integer. So let's double check these asymptotes. 1, 2, 3, 4, 5. So this is 5 pi sixths. And in between asymptotes is 1, 2, 3, 4, 5, 6 tick marks. Each tick mark is a pi sixths. 6 times that is pi. So that verifies our asymptotes. And what we have here is sketch the secant wave based on this minus cosine wave. All right, hope this helps.